So I combined two different kind of topics. We're going to do analyzing F prime and F double prime, and we're also going to talk about graphs. Okay, I kind of cut a couple of things up and I put it into one packet. I'm not going to go over this whole thing right here. Okay, I know it's a little blurry right here, but it should be clear on your paper. These are notes for your use. Okay, I do want to say that if you're asked about increasing, decreasing, relative min, relative max, that's first derivative stuff. What's second derivative stuff? Concavity, and what do you call it when the concavity changes? A point of inflection. Okay, so there's a lot of stuff here, a lot more than you probably really even need, and that's just there for your reference. Okay, I want to spend time going over. Why is that not there? Let's say it good. All right, that's fine. I'm moving on. So I want you to look at number, and I'll just write it up here. I want you to look at number 2. Okay, so for 2, it gives you f of x equals 3x to the 5th minus 20x cubed, and it asks about when this graph is concave up. Okay, so what do we need to do? Take the derivative. So f prime of x equals, just use good old power rule, 15x to the 4th minus 60x squared. And then now what do we do? Drive it again. So that's going to give me 60x cubed minus 120x. Okay. Now what? So I'm going to set this equal to 0, and these are not actually called critical numbers. Critical numbers are where the first derivative equals 0. These I'm going to call possible points of inflection. So PPOI, that's right. All right, so to solve this, we need to factor out a 60, and I can also factor out an x. And what I'm left with is x squared minus 2. And so when you set 60x equal to 0, you get x equals 0, so we have a possible point of inflection at x equals 0. And then when you set x squared minus 2 equal to 0, what does x equal? Plus or minus root 2. Okay, so I have 3 possible points of inflection. So here's how you know whether it is or isn't. All right, you put them on a number line. I don't know why this is so thick. It's okay. Put them on a number line. And then down here, I'm going to write f prime. Up here, I'm going to write f. Okay. Or yes, sorry, thank you. F double prime. Now, you can choose either version of f double prime. I'm going to choose the factored form. So take a number to the left of negative square root of 2, negative 5, okay? If you plug in negative 5 here and here, would you get a positive or negative result? So 60 times negative, and then negative 5 squared minus 2, that's going to actually be a positive. So a negative times a positive is a negative, which means the graph is concave down right there. Okay, so we plug it into the second derivative to figure something out about f. Now typically, on a lot of problems, what happens from here? It goes from plus to minus and minus to plus. It's a good idea to check it, but I am going to tell you that that is what happens here. Do you remember how to tell by looking at the algebra if it is going to go back-to-back pluses or back-to-back minuses? If you had something like this, like x minus 1 squared, then right around that 1, it would either be plus on both sides or minus on both sides, and 1 would not be a point of inflection.
It's because
okay?
It doesn't cross through.
Doesn't cross through, it bounces off graphically. Exactly. So this is what my graph looks like in terms of the concavity. So our problem was concave up. So our answer, if we had to write it out, would look something like this. All right, now which of the answer choices looks like this? None of them look exactly like it, but which one's equivalent? B. Very good. Okay. What I would like for you to do now is to turn all the way to number 14. Okay, and I want you to notice this packet really isn't that long anyway. Okay, so for number 14, they give us this function f of x equals x e to the negative 2x. And they also give us a domain. They say this is all always happening between 0 and 10. That's going to be important for part B. So for part A, it says, when is this graph increasing? Or sorry, decreasing. Well, it says both, sorry. Both increasing and decreasing. All right, so what do we need to do? Drive it. Hey, on a free response, if you have no idea how to do it, just drive it. That might get your point. Okay, so I'm going to use product rule. Derivative of x is 1 times e to the negative 2x. Okay, plus just x times the derivative of e to the negative 2x, which is e to the negative 2x times negative 2, right? The derivative of the power. And we're going to set this thing equal to 0. These are going to be my critical numbers. This is like where the graph may change from increasing to decreasing, or vice versa, okay? We're going to factor. What can you factor in this problem?
E to the negative 2x.
E to the negative 2x. And in the first group, you're left with a 1. What are you left with in the second group?
X and negative 2.
An x and a negative 2. So I'm going to write that as a minus 2x. Okay, here's the good thing. E kind of brings up some weird stuff, but here's a good thing about E. E to any power or any number is always positive. It's always greater than 0. So this is not giving you any critical numbers. It can't equal 0. It's always going to be positive or greater than 0. So my only one I have to worry about is this part right here. So when you set 1 minus 2x equal to 0, what does x equal? 1/2. Okay, so this is like a possible max or min. Right, so I'm going to go ahead and make a chart over here. 1/2, down here, f prime, up here, f. All right, so let's take something over here like 0. Now again, when you plug it in, it's awfully nice to remember that e to the negative 2x is always positive. I don't care what x is. Small, big, negative, positive. E to anything is always positive. So I really only have to say, okay, well, what is 1 minus 2 times 0? Is that positive or negative? Positive. So right there I have increasing. Okay, over here, probably it's going to change to decreasing. You can double check it, plug in something like 1. You do get negative, so f is decreasing. So to answer the question, we're going to say f is increasing on. Okay, now pay attention to the fact that they told us we had a domain. Okay, is f increasing on negative infinity to 1/2? No. It's increasing on 0 to 1/2. All right, now here's the deal about should there be a parenthesis or bracket here. Okay, you're good either way. Okay, if we had to put a reason, we would say because f prime is positive or greater than 0. So we're going to write a similar statement. F is decreasing, because it asks for both, on 1/2 to not infinity because we had a specific domain. Because f prime is less than 0. All right, so now we're going to do the next part. are they asking on the next part?
Maximum and minimum.
They're asking about for absolute extrema. All right. Now, 1/2 is a relative what? Max. Okay. 1/2 is a relative max. They didn't ask for that. So 1/2 could be the absolute max. Okay. Or where else could it happen? And it probably is, but where else could it happen? The endpoints. Definitely, I don't know where the absolute min is. So when you're doing absolute extrema, if you kind of use logic, you can usually figure out, like narrow it down. But in the end, you're going to have to test the endpoints and the critical number. Okay, we're using the original equation. We're not using f prime or f double prime. We're using the original equation because I'm trying to figure out what is the highest and lowest point on this graph. Okay, so what is f of 0? Well, using that original equation, it's going to be 0 times, well, I don't care, whatever, it's 0. As soon as you go 0 times, you got 0 there. Okay, what about f of 10? Okay, remember the function was x times e to the negative 2x. This is kind of strange.
But if it's positive, then will it be bigger?
So definitely this is bigger than 0. Okay? And I like that you said that, so we might come back to this. But so far, 0 is the smallest one, because e to anything is positive. All right, do you think f of 1/2 could be the absolute min?
No, because 0.
No, because probably for the same reason, and because,
Increasing.
yeah.
Or it has, you know.
So this would be like 1/2 e to the power of negative 2 times 1/2. Okay, so the absolute min, it wants the x and y coordinates. Oops. So the absolute min is happening at 0, 0. Okay, where is the absolute max happening? So there's a couple of different things we can do to figure this out. One thing is, if you're not quite sure, I mean, this is without a calculator, if you're not quite sure which of these is bigger, you could think about the fact that from 1/2 to 10, the graph is decreasing. So, could the max be at x equals 10? No, it has to be at 1/2. Okay, let me show you another way, and I'm going to write this as e to the negative x. I'm losing a little bit of juice here, guys. Okay, so I'm going to rewrite this. This is 1 over 2e. This is like e to the negative 1. That's 1 over 2e. This would be 10 over e to the 20th. I mean, e is about 2.7. So when you take something like that to the 20th and you divide, that's going to be a pretty tiny number. Okay? So those are a couple of different ways to figure out which one's which.